Hey everybody, this is Gregory from Dapp University, and today I wanted to show you how you can get started building your first decentralized application in 20 minutes. So the goal here is to give you the tools that you need to get started building a decentralized application, or Dapp, quickly. So what I'll do is give you all of the individual components that you need to get started, and we'll go from there. So you might have seen my other tutorial where I show you how to build a full decentralized application step by step with a framework like Truffle. So in this tutorial, I'm not going to use a framework, and there are a few reasons for that. Reason number one is that whenever you use a framework, sometimes there are a lot of things that you take for granted that are just happening with your framework that you get for free, and you don't necessarily understand, how this works. So today we're going to strip away the framework, and you'll be able to see how each of the pieces in your Dapp kind of works on its own. Now, the other goal of not using a framework is to get you started faster. When you use a framework, you have to download a lot of stuff and do a lot of things via the command line, and sometimes that gets people a little hung up. So if you want to remove that barrier to entry, we'll do that with today's tutorial as well. So, like I said, if you haven't seen my tutorial where I take you through, step by step in building your first decentralized application, be sure to check that out, because at the end of this video, I'm going to show you why you really do want to use a framework for building dApps. It makes things a lot nicer in the long run, but this will give you something to get started. And be sure to subscribe to the channel if you'd like to see more videos on how to build your first decentralized application on the Ethereum network. All right, what are the basic things that we need in order to build our Dapp quickly? Well, from a code perspective, we need a smart contract, and we need a client-side application that will talk to this smart contract on the blockchain. So for the smart contract, we will develop this in Remix, which is a browser-based IDE that allows us to write our smart contract and compile it and run it. We also need a blockchain to deploy our smart contract to, and for local development purposes, we will use Ganache, put out by the creators of Truffle, the framework that I use in my other tutorial. And Ganache is basically, an in-memory blockchain. It's like a one-click blockchain. So this is the only thing that you'll need to download locally. You can download this and install it. And once you open it, it's pretty straightforward, pretty simple. It will just start running, and you'll have 10 accounts connected to your blockchain for free. Now, the next thing that we need, there are two other things. We need a library that allows our client-side application to talk to our smart contract on the blockchain, and that's what Web3.js is. This is the Web3 library, which is what we'll use to connect our smart contract to our front-end application. The last thing that we need is a browser extension that converts our modern web browser into a blockchain browser, because most web browsers don't support this out of the box for free. We will use MetaMask, which is a Chrome extension that will allow your browser to talk to the blockchain. It's pretty simple to install. You just add it to your Chrome extensions and set it up. If you need help setting this up, I walk you through setting up MetaMask and a couple of these other libraries step by step in my other tutorial, where I walk you through building your first decentralized application. And I can post a link to that down in the description below. So let's go ahead and dive in. First, let's look at our smart contract code and also kind of the client-side application that we'll be developing. This is pretty simple. I'm going to post a link to this in the description below. This will be deployed to GitHub. So essentially what we'll do is we'll have a really basic, index.html file that will have our application layout, and I'll write some JavaScript down here, and we will use this smart contract that I've written. It's just a really basic contract, and we'll just kind of copy and paste this into Remix in order to compile it and deploy it. Now you'll see some other stuff in here like CSS, fonts, and JavaScripts, and this is really all just external libraries that I've imported so that we can get up and running quickly. And specifically, it's just the Bootstrap library so that we can have some nice looking UI. And the other main component is the actual Web3 library that I mentioned a second ago. And this is the library that we'll kind of look at in depth or in detail when we develop this little front-end application here. So let's take this smart contract. We'll copy it. And this is kind of the beginnings of the smart contract that I build out in my other tutorial where we build a full voting decentralized application. Go ahead and paste in your smart contract code. So let's take a look at this for just 1 second. This smart contract is pretty basic. All it really does is display a candidate name. We'll just read the candidate name here. This is going to be our only candidate in this election. And it also allows us to just update this candidate name. And in the other tutorial, I kind of walk you through how to, we can add candidates and we can vote for candidates and we'll tally up votes. But for now, we're just going to do something very simple to know that our, client-side application is actually talking to our smart contract. And, you could go from there. So what we need to do, first of all, is ensure that Ganache is running. See this here? Just download and install Ganache and launch that, and you'll see that you have 10 accounts here with a balance of 100 Ether. And you'll need to take note of the port that Ganache is running on. Mine's running on 7545 by default. So we'll go back to Remix, and we will change the environment. Now, by default, over here in the Run tab, yours is probably set to JavaScript Virtual Machine, or maybe Injected Web 3. I'm going to choose a Web 3 provider. And it'll ask us if we want to connect to an Ethereum node. And essentially that's what Ganache is going to give us, is a local node or an RPC instance. And so I'm going to update this to 7545 because that's what we saw Ganache running on. Click OK. And once that's connected, you should see the accounts available in Ganache. So I'm going to select this first account right here with this one right here, the 100 Ether. And I am going to deploy the smart contract by clicking Create. And we can see that this was deployed by looking at the transaction receipt below. And we can call the functions on a smart contract here. Let's get a candidate name. And we can see that this is the variable here, set to candidate 1. That's what we expect because we see the default value getting set in our smart contracts constructor. All right, now that our smart contract is deployed to our local blockchain, let's go ahead and look at our client-side application. So first of all, we'll open our index.html file and we'll take a quick tour here. So what we'll have is just a place to hold our candidate name to display it. And we'll have a form to update that candidate name. And this code's pretty straightforward. Like I said, I'll post the link to this code down in the description below, and you can read through it. And what we'll do is write our our client-side application here. And like I said, if I was building a real Dapp, but we'd have, much more files for this or even a front-end framework. But for now, I'm just trying to show you very simply what each component does, particularly how Web3 works. So in order to make all this work, I'm importing, Bootstrap, and I'm importing the Web3 library so that we can configure it and get our client-side application to talk to our blockchain. So we'll take this index.html file, we'll open it in Chrome to kind of see what we have. All right, so this is our basic UI. We'll just have the candidate's title here. And what we want is to list the candidate name right here. And we want to wire this form up to talk to our smart contract and add the candidate. Let's start writing our client-side application JavaScript. I'm going to just paste some code in here that initializes Web3. That's the first step. So remember, we need a way for our client-side application to talk to the blockchain. And there are two kind of actors in this scenario. One is the Web3 library itself, and the other is MetaMask. So MetaMask is going to give us a provider in our web browser that we can use to talk to the blockchain. So what this code does, it says, if this Web3, if Web3 is there, we want to take the current provider. And this is the provider that would be, given to us by MetaMask. So we would set that here as the Web3 variable. It's not provided by MetaMask, then we'll just default to an HTTP provider that's on our localhost node. And this is the URL and the port for my Ganache instance. So the next thing that we do is set the account for Web3. So, MetaMask allows us to interact with the blockchain, and in order to interact with the blockchain, we need to know which account we're using. So we can actually tell Web3, the default account. And what we'll do is get access to the first account that is provided to us by MetaMask. And we do this with web3.eth.accounts, and we'll just take the first one because this is a zero-based, index array. This is the first one. And we tell Web3 that this is now the default account, and that's the one that we will be, acting on behalf of. Now, the next thing we need is a representation of our contract on the client side. And we can do this with Web3 by using the web3.eth.contract function. And this is going to expect an ABI. So an ABI is an application binary interface. This is basically going to be just a big JSON object that represents your smart contract that the Ethereum virtual machine understands. And we can also use that to reconstruct our contract for something like Web3. So we'll have a way to call the functions of our contract with Web3. Like we can get the candidate and we can update the candidate and things like that. So what we'll do is we will pass in the contract ABI here. And we also want to, so passing in the contract ABI kind of tells, Web3 what our contract looks like, what functions exist on it and things like that. So the next thing we need to do is tell it exactly which contract to use on our blockchain. So we do that by passing it the address of our contract, and we can just do it like this. And we'll just say contract address. So we'll declare these variables here. Let's set contract ABI. We'll call this. We'll set that in a second, and we'll say set contract address. Say var contract address. So we'll fill these in here in just 1 second, and then we'll tell Web3 about these two things, and this will kind of give us a representation of our contract that we can use on our client side. All right. So let's grab the contract ABI. We do this by going to Remix, and we go to Compile. Once we go to Compile, we click the Details button, and we can see the ABI down here. ABI section. We'll just copy this, and I'm going to paste this here, contract ABI, and we'll do that like this. All right, so we can see this is just a big JSON object that kind of tells us what the outputs are, things like that. These are the functions that our contract responds to. So I'm going to just minimize this for kind of screen real estate. And we'll also need the contract address, and we can also get this in Remix. So we'll go to the Run tab. We'll find our contract that we deployed, and we'll click this little copy symbol here. This will copy our contract address. We'll go to, do that as a string. Set our variable. All right. All right, so now these are filled in. We know what our contract ABI is and our contract address. And we'll pass that into Web3 contract function, and we'll tell it which address to use the contract from. And let's go ahead and set this to contract. So now we've got, Web3 configured, and we have, a representation of our contract that we can use in our client-side application to, kind of write some code to make this client-side work for our decentralized application. Let's do just that. Let's write some code. So first thing we'll want to do is let's just display the candidate name. So if we go back to our application here, we essentially just want to see the candidate name right here. So let's just display candidate name. We'll do that with contract, which we just defined right here on line 102. We'll do candidate name. Like I said, this is just a representation that will allow us to call functions on our contract. And then we need to pass it a function. We'll give it error, and then candidate name. And let's say, let's see, we want to display the candidate name here. Actually, I have a conflict. Let's actually call this. We don't need this. Let's take this off. This would be, all right. Yeah, we'll use ID candidate name for this H4. We'll say candidate name. We'll pass the HTML, candidate name. All right, let's see if that worked. Let's go to MetaMask and ensure that we are connected to the correct network. Let's reject this. All right, private network, we're on Ganache. All right, let's try to refresh. Boom, there we go. We can see the candidate name listed here. All right, the next thing we want to do is provide a way to update that candidate name. The candidate name. So we'll basically find our form for updating the candidate, this form right here. We'll find the form, we'll say on submit, pass it a function, give it the event, we'll right, we'll go ahead and prevent the default behavior here because we don't want to trigger a page refresh when we submit the form. And we'll do contract, we'll set candidate. Remember, this is our function that we have here, set candidate. Contract set candidate. Let's grab the value. So this form is going to have an input here. Yeah, right here, candidate name. And we'll just find the only input available. Input, say val. And oops, looks like I made a little typo here. This will be candidate. So, all right, so let's save that. We'll go to our browser. We'll refresh. Take this out. All right, let's try to update this value. Say candidate 2. Oops, 2. Candidate. Boom, there we go. All right. You can see that we're actually updating values because the candidate name changed. We can update this back to candidate. Let's just say foobar. Got candidate. Boom, foobar. All right. Now we can, put your name here. You can do anything that you want to. This gives us the ability to read and write information from the blockchain, full stack. So we have a client-side application where we can connect to the blockchain, connect to a smart contract, where we can read some data. We can read a candidate's name about the election. We can also update that candidate's name as a value. So this gives you the very basic tools that you would need to get started doing those kinds of things. Just connecting any kind of HTML file to a smart contract on the blockchain. You would just need, some sort of representation of that smart contract, an ABI. You need a Web3 instance in order to make use of that ABI and an address for the contract that's deployed on the blockchain. And you can start, kind of going away with just that. All right, so those are all the individual tools that you would need. Now, earlier I mentioned, that we wanted to do this outside the context of a framework, but when I'm actually developing a decentralized application, I want to use a framework. And here's why. This contract ABI, I don't want to copy and paste this anytime, I make a code change. So if I'm developing a smart contract and I add functions, I would have to copy and paste this into my file every time. Something like Truffle actually handles that for you. And I don't necessarily talk to the, Web3. I don't have to set my, contract from that ABI every time. Truffle actually has a Truffle contract library that does all that for you, which is really nice. And also, I don't have to change the address of this contract every time that, gets redeployed. So that's really nice. And there's a lot of other stuff you get for free with Truffle. Like testing, there's some nice stuff for deployment. I can specify different networks, so I can deploy this, locally. I can deploy it on a, test network or the main network. And also, I wanted to show you that you can do lots of other stuff with this, tutorial. When I set my, RPC instance here, I could change this to any Web3 provider that I want to. I could specify a remote RPC here. So if you wanted to host an Ethereum node on a remote server, you could connect to it that way. Or if you were, developing with a different technology locally, like Geth, if you've used the Go implementation of Ethereum before, you could plug in the port for Geth running locally. That's actually typically defaults to 8545 on a Mac. That's kind of probably why this is the default value here. So that just gives you some ideas of where you could go with this tutorial. And again, if you haven't already, check out my other, 2-hour tutorial where I walk you through developing a full decentralized application step by step, and I'll show you the Truffle framework and walk you through all of that. So I hope this helped. Hope kind of shed some light on how Web3 works and some of the more rudimentary steps that you would need to take in order to build a decentralized application quickly. Be sure to thumbs up the video and subscribe to the channel if you'd like to see more videos on how you can get started building decentralized applications on the Ethereum network. And until then, thanks for watching Dapp University.